to work is similar to the first problem that you have on your homework tomorrow. So hopefully it'll help you work through that with this as an example. Here you're given an equation of velocity in terms of x, and you'll have to find the position equation in terms of time, velocity equation in terms of time, and acceleration equation in terms of time. When you do that, you have to convert it, which is really great. We'll get to that integration in a second, but it also gives clues, and you'll know when you work 1,000 of these problems that you'll have to find the initial conditions of position, the final position, and the final time. If you're working a problem that you're dancing through equations and you don't really know where to start, probability that you have to solve for the final time is very, very high. So if you're lost and you have no idea what to do, start solving for the initial and final time, which usually initial is 0, as it is here. So just solve for the final time, and hopefully as you're doing that, you'll kind of figure out what you need to do. There are cases where you only need this equation, velocity in terms of x, and so you'll never have to get anything in terms of time, but that's on the rarer case. So just, if you're lost, start solving for time. Here though, we're going to solve for the initial and final position by solving for this x here. X naught or S naught, because I want to use these interchangeably because S is very similar to X and the textbook is going to have both. So we're going to be using both in this problem. That is V over 3 cubed, which is 3 cubed, 9. So S naught equals 9. S final is 15 over 3 cubed, and that is 25. And this here is the initial, and this one is the final. That is fairly straightforward to find the initial and final position. So I'm going to go ahead and erase this so we can free up some space. Okay, the easy part, I guess you could say, is out of the way, but we still don't know time. And we still don't know these equations. So remember, before the exam, before spring break, before all this other nonsense, I had talked about how v equals dx dt, or it can be noted as ds dt. And in our case, we know what v is, and it is 3x to the 1/3. If you are just to look at this portion here and completely forget that v is part of this scenario, then you have a nice equation that's going to be just in terms of position and just in terms of time. So let's take this down and integrate it. Move the equation to the other side so that you have everything in the correct position. This is t naught, which we have as 0 here. And then t final, which we don't know yet. And then we have s naught, which we know equals 9, and s final, which we know equals 25. Once you integrate this and plug in the values, you will have a nice equation. Well, let's do the intermediate step because we'll need that later. X final 4/3 minus x naught 4/3 all over 4. And from earlier, we found that this is equal to 9. So you'll get that the time final is 25 4/3 minus 9 4/3 all over 4, and that equals 13 seconds, which is great because we need that up here. And we'll need that later, but for now, let's go ahead and solve for x final. When you solve for x final, you'll get that 4t final plus x naught 4/3, 3/4. And we'll plug in 9 for this. So that also becomes 4t final plus 19 to the 3/4. And this is the first equation because this is in terms of time. And that means that you can plot it on what that curve would look like in terms of time, whereas before we had velocity in terms of x. So that is very convenient. Now let's move on to getting velocity in terms of time. And as I mentioned just a second ago, you can take the derivative of it. So this is going here, and you get d of 4tf plus 19 to 3/4 over dt. And when you derive that, you'll get 4/3 times 4 times t final plus 19 to the 1/2. And that is equation 2. Derive that once again for a of t, which is dv dt. And you'll get 16 over 3 times 4 over 2 times 1 over 4t final plus 19 to the 1/2. And let's simplify that a little bit to make it look pretty. 16 over 3 times 4 over 2. Nope, that's not a simplification. Let's not simplify that. Plug that into, I used Wolfram Alpha to solve for it. You can use a calculator, whatever you feel comfortable with. Because we know that this is equal to 13 here. So solve for that at the final point, and you get 1.3 meters per second squared. So earlier I had said that we would need time. If you had not solved for time earlier, but just were like focused on the equations of x in terms of t, v in terms of t, and a in terms of t, and you get here and you don't have this t of f, and you freak out because you have an equation, but you're still looking for acceleration, you don't really know what to do, you can always go back and solve for it. And there's a couple ways that you can solve for it. You can solve for it by putting in your x final, because you know that. Or you can solve for it by putting in your v final, because you know that. Either way, you can get this t of final time, because t is the connector of all equations. I like to see it as the very center, and spindling off of that are all of these equations, because time doesn't change. It's always consistent. So just always rely on time. So when you put in 13 seconds, you can solve for the final acceleration. So as always, with problems like this, let me know if you have any questions. Send me an email. I'm going to start a discussion so we can talk about these problems together. But since we're long distance now, it's not quite as easy to come in my office or even ask questions as I did this explanation. So please email me. I may not respond right away, but I will respond. Also, sometimes my responses will be like, okay, and very, very short. That's out of convenience for me, not because I hate you. So if my response is okay, period, just know that I was still glad that you emailed me. It just didn't require a long response. So there is The problem